Okay, dear students, welcome to Spark Academy. I am Nityanand Ghosh, physics faculty here. So basically, I will be explaining you about units and dimensions. Already I explained before, but let me revise quickly. And then actually, once you know the units, you will get units depending upon the formula of different physical quantities. So now this class, you will be actually, I'll be teaching you about different physical quantity, and then what are their formulas. Sometimes, same physical quantity, the formula will be different. For example, suppose if I say the relationship between force and the magnetic induction. So there are two formulas. One is F is equal to Q V cross B, another is B is equal to mu naught I by 2 pi d. So B has got two different formulas. So once you know the formula, you will be knowing the units, and once you know the units, you will be knowing the dimension. So this is what I am going to teach you now. So now, as I told you before, that there are two types of physical quantity. One is fundamental, another is derived quantity. Derived is nothing but derivation. There are 7 independent quantities are there. Next slide you will see. Most basic is mass, length, time. They stand independent of each other. You cannot mix them. So they are the most fundamental. Using them, you will get different physical quantities, derived physical quantities. So now in this slide, these are the 7 fundamental quantities. One is mass, M, another is length, L, time, T, electric current, A, temperature, K, luminous intensity, candela, and amount of substance, mole. 1 mole of a substance, it is equal to suppose 1 mole of oxygen, it is 16 grams, 1 mole of carbon, it is 12 gram, or it is 6.023 into 10 power 23 atoms, molecules, ions. MK system is 6.023 into 10 power 26. Okay, all those things you should know. Okay. Okay. Now next slides. So these are some of the basic derived physical quantities. Derived physical quantities. What are derived physical quantity? First is velocity. Velocity is nothing but, velocity is a vector quantity. It is rate of change of displacement. That is distance travelled in a particular direction divided by time. So mostly, when you write the formula, it is distance by time. So LT minus 1. For completeness, you write M0 LT minus 1. L to the power of T minus 1. Similarly, force is equal to mass into acceleration. So mass is M, acceleration is LT minus 2. Because acceleration is velocity by time. Velocity is LT minus 1 divided by T. If T goes up, it is LT minus 2. So M0 LT minus 2. Okay. So for mass, it is M into acceleration. So this is MLT minus 2 is the dimension for force. Like that in chart, different dimensions you can see. Okay. So here about the different system of units. For competitive exam, you should know. For competitive exam, you should know these two very well, CGS and MKS, because CGS is nothing but length, mass, time is denoted by centimeter, gram, second. Similarly, in MKS system, length, mass, time is denoted by meter, kilogram and second. Okay. So if by chance in a numerical problem they are asking force and they give mass in gram and acceleration in, if they give centimeters per second square, it is okay. Both are CGS. But mass they are giving in CGS system, that is gram, and acceleration they are giving in MKS system. If you try to multiply, you will get wrong answer. So either convert all physical quantity into CGS unit or all quantities into MKS unit, then only correct answer you will get. Now this is foot-poundal system. Foot-poundal system, length, mass and time is denoted by foot, pound and of course second is second. 1 foot is equal to actually 12 inches. 1 inch 2.54. So if you multiply 12 into 2.54, you will be getting 1 foot in centimeters. And roughly 1 pound is less than half kilo. So 2 pound will be roughly 1 kg. So these are the conversions. Now this tabular column, some of the physical quantities are given. They are nothing but you can see density, acceleration, force, energy, power, pressure, viscosity, all these units in MK, CJs it is there. But before that you should know the formula. Volume is L length into breadth into height, so L cube. That's why feet cube, meter cube, centimeter cube. Density is actually mass by volume. Unity formula is very important. That's why kg per meter cube or gram per centimeter cube. Similarly, acceleration is actually meters per velocity by time square, no? So meters per second square. Force is mass into acceleration. Mass into acceleration. So mass into force is equal to mass into acceleration. So mass is actually kg, acceleration is meters per second square. You can also write Newton. MK's unit of force is Newton. CJ's unit of force is dyne. 1 Newton is equal to 10 to the power of 5 dynes. This is also one conversion. CJ's to MK's, MK's to CJ's. Okay. Similarly, pressure. Pressure is equal to, pressure is nothing but it is force per unit area. Accordingly, you will get the dimension. Or Pascal you can write Newton per meter square. This is easy unit to remember. Power is equal to rate of doing work. So once you know the formula, you will get the units in CJs and MKs. So now this is very important, homogeneity. In dimension, what is the meaning of principle of homogeneity means? Any two physical quantities you can add or subtract on either side of the equation, provided the dimensions are same in both sides, left hand side as well as the right hand side. I gave some example. V is equal to U plus AT, S is equal to UT plus half AT square. You know all this formula, you know. Sn is equal to U plus A by 2 into 2n minus 1. Okay, and in gravity A is replaced by G. All they are correct. Why? Because suppose if I take S is equal to UT plus half AT square. The dimension for S is L. UT, dimension for velocity is Lt minus 1 into T. So it will be, when the bases are equal, powers can be added. So L minus 1 plus 1 is 0. Anything to the power of 0 is 1. So it is L. Similarly, this problem, they ask in the exam. This is a van der Waals equation or gas equation. The unknown quantity here is A and B. A and B is unknown quantity, let's say. If you want, you can represent, suppose A and B is unknown quantity. They are asking what is A by B or AB minus 2 or AB minus 2 is equivalent to which physical quantity? Is it equal to Planck's constant? Is it equal to energy density, torque, angular momentum? So first and foremost, you should find out the dimension of A and B. So dimension of A and B, how you use the principle of homogeneity, the dimension of B will be equal to V, volume. So, dimension of B will be equal to dimension of V, that is L cube, correct. That is what is homogeneity says, the dimension of this and these are equal. Don't bother about minus, plus, all those things, leave it. Similarly, P means pressure. So dimension of A by V square is A by V square, the dimension is equivalent to P. So you find out the dimension of P equal to A by V square. So A will be V square into dimension of P. P is equal to pressure is equal to force per unit area. Force is equal to mLT minus 2. Area is L square. So you will be getting ml minus 1 T minus 2. This is equal to A by V square. So a to the power of L to the power of 6. So dimension of A will be L to the power of 6 into this. So you will be getting M L to the power of 5 T minus 2. You will be getting the dimension for A. So you know the dimension for A, you know the dimension of B, you can substitute and find out. And this happens to be equal to some competitive exam they ask, this is equal to energy density, that is energy per unit volume. Okay, energy work dimension you know divided by volume, you will get the answer. Okay, so basically application of dimension is you can check the correctness of an equation. Whatever equation is there, you can check it by using dimension. Is left hand side is equal to right hand side. You can check. Okay. Similarly, you can derive the relationship between different physical quantities. See, if I say what is power? Power is work by time. If somebody says no, power is equal to force into velocity. Because power is force into distance by t, distance by time is velocity. So power, one more dimension is force into velocity. Suppose if you don't know the formula, some doubt is there, then you can find out the dimension for pressure, find out the dimension of force and velocity. Both left hand side will be equal to right hand side. Like that, this is the coefficient of viscosity. What is viscosity? Viscosity is friction between two liquid layers. You think that liquid, when it is flowing from one point to another point, think that there are different layers. So let's say each succeeding layer will be traveling faster than the previous layer. So if one layer travels faster than the previous layer, there will be some retardation. If you throw a bucket of water, how it goes? If you throw a bucket of honey, how it goes? So that is what is viscosity, coefficient of viscosity. So coefficient of viscosity, the formula is force of viscous drag divided by area of cross section into velocity gradient. Okay, so like that you different derived dimensions you can get. Okay. And this is one how to get a formula. How you get this formula? This is the time period of a simple pendulum. And on this time period simple pendulum, so many different types of problems are asked. They will ask. Of course, in your physics lab, you found out the acceleration due to gravity. G is equal to 9.81 meters per second square. That in the lab you found out. You suspended one bob, and this is with the help of a string, and then you made it to oscillation, and you found out the time period of 20 oscillation, time taken for 20 oscillations, then you can find time period of 1 oscillation, and then you found out L by t square. Once you know length, once you know time period, time square, L by t square, and from graph also, if you plot a graph between L versus t square, it will be a straight line passing through origin. From that, from graph also we will find out G. So this is a standard formula. And of course this length to know why pendulum type of watches are there. No, quartz watch is there, pendulum type watch is there. Quartz watch is run by battery, pendulum watch, why in the summer it runs slow, why in winter it runs fast. So the length changes actually. So length changes means another formula comes. L is equal to LT, LT is equal to length at T, some T means temperature, not time. It is equal to L0 into 1 plus alpha into T2 minus T1. Here alpha is nothing but coefficient of linear expansion. They will ask what is fractional length, what is fractional change in length, what is the percentage change in length. Then what you do here? If you open the bracket, you will be getting L0 plus L0 alpha into T2 minus T1. Okay, this is equal to LT. So LT minus L0 is increase in length. This is equal to L0 alpha T2 minus T1. And this L0, if you bring it down, you will be getting LT minus L0 by L0 is equal to alpha into T2 minus T1. This is a fractional increase in length. They will ask percentage. Percentage means both side into 100 you have to do. Both side. Both side. So this is the direct formula in NCERT, IIT or whatever engineering medical entrance you are writing in our country. This is the direct formula. Alpha, they will be giving T2 minus T1 is difference of temperature into 100. Okay, so like that, connecting formulas are there. Once you know all the different formulas, then in a given situation, how to use that? See, they will be asking a numerical problem and they will be giving you some data. From that data, you have to visualize the formula and quickly you have to solve the problem. That should be your motto when you are attempting any competitive exam. So anyhow, this particular thing, the time period of simple pendulum depends upon mass, length and acceleration due to gravity. You don't know what is the relation. So initially, let it be mass is raised to the power of A and length is raised to the power of B and G is raised to the power of C. Then you proportional, you remove this, put one K and then you use write the dimension for M, L, G is acceleration, LT minus 2 and that power you multiply and you collect the power. When the bases are equal, powers can be added, both sides you equate and get the value of A, B and C, substitute, we will get this formula. That is what is being done. This is the dimension for T, this is the dimension of M and this is the dimension for G. You substitute and then you open the bracket, L, B plus C, bases are equal, powers can be added and then T minus 2C, and equate the power of M, L, T on both sides, you will be getting A is equal to 0 because the power of M is A, here the power is M is 0, so A will be 0. Here the power of T is minus 2C, so minus 2C is equal to 1 means C will be minus half. Similarly here if B plus C is equal to 0, B will be equal, B plus C is your minus half, so B will be half. If you substitute the value of A, B and C in this, you will be getting this formula. Okay, K of course experimentally found out, K value will be 2 pi. Like the different formulas, first see in physics what happens is there are two types of research. One is experimental research, another is theoretical research. Theoretical means simulation will be there where the scientists, they will be sitting with so many literature, so many books and they will be writing a program and they will try to arrive one solution. Experimentalists will do experiments in the lab. All the experiments can be done in the lab and then you can check. So theoretical and experimental research, there should not be much gap. Then only the scientific community accepts that actually. There are some drawback in dimension. You cannot apply dimension to constants. Pi, 2, sin x, cos x, e power x, tan x. So you have to ignore that. In dimensional formula, suppose if I write f is equal to 6 pi, if I write f is equal to 6 pi eta a b, suppose if I write, this is viscous drag. So you have to neglect this 6 pi. You neglect, just put the dimension of eta a and b. Okay, and this will be equal to force. You have to ignore 6 pi because no dimensions. And it does not distinguish whether it is a vector quantity, scalar quantity. All have dimensions. And then here there is a big chart. This chart you can just follow. And then the main thing is actually all the formula. Velocity is mass by time, velocity is distance by time, then you can put dimension. Momentum is mass into velocity, acceleration is velocity by time, normal velocity by time, force is equal to mass into acceleration, impulse is equal to force into time. Actually impulse, a large force acting for a short duration. Okay, suppose for example, you are playing cricket. When catching a ball, you don't catch a ball like this. You have to increase the time. Increase the time, you have to put your finger back and then catch, because if the duration, if time is increased, force will be decreased. So effect of force on your palm will be decreased. If you try to catch the ball like this, first there is a chance of ball falling down, or next force will be more because time is less now. So that is the beauty of physics. It is actually applicable in each and every occasion, in each and every field, and the problems on the surface of the earth, will be solved by applying the funda of physics. Okay, so here formula is very, very important. If you know power, work by time, all these things you should know. Like that, so many charts are there. I will show you the charts. See, this is one chart. Anything, suppose you take stress, stress is force per unit area. Force per unit area. What is strain? Change in length by original length. No dimension. Because LL cancel. Young's modulus is what? Within the elastic limit, stress is proportional to strain. So stress by strain. Strain no dimension. Stress force per unit area. You know the dimension for force and you know the dimension of area. Just substitute, you will be getting. Surface tension means what? Force acting per unit length on the surface of the liquid. Liquid acts as a stretched membrane. See, suppose you take a glass of water. You take a alpine. You just put alpine on the water, it will float. Don't put the alpine like this. If you put the alpine like this, what happens? The mass of the alpine and the gravity will act on it. Force F is equal to mg. You know the density of alpine is more than water. Actually, it should sink. It is not sinking. So that is the beauty. And you can see that suppose you take a tumbler of water, you go on adding water. At the end also some more water will be there. That is because of surface tension. Okay. So what is force constant, spring constant? F is equal to kx. Actually F is equal to minus kx. Because this force is called restoring force. Simple harmonic motion mein always the force will act opposite to the displacement. So in physics, opposite means minus sign will come. But K is called force constant or spring constant. So K will be equal to force by X. Force by X. So ML force is MLT minus 2 by L. So LL cancel. So MT minus 2. Okay. Okay. So here, here. MT minus 2. Okay. See, force and spring, surface tension has got the same dimension. Surface tension also force acting per unit length on the surface of the liquid, and your force constant also force divided by length. Like that. Coefficient of viscosity, as I said, F is equal to eta A dV by dx. Okay, so you can put the dimension and then eta force A velocity x you will get the dimension. Okay, similarly gravitational constant, the formula, universal, every two body will attract, body will not repel. So this is the universal. You remember apple fell on Newton's head instead of tree, apple fell on Newton's head. So this is the formula, F is equal to G m1 m2 by r square. If by chance one minus sign is there, that means attractive force. Okay. So from there you can G. The value of G, G will be equal to 6.67 into 10 power minus 11. What is the unit? Newton meter square per kg square. So you frame the equation for G. G is equal to F into r square divided by m1 m2. So you know the dimension for F, you know the dimension for length, and then m1 into m2 will be m square. So you know the dimension for G. This is another tabular column where charge, current. Okay, current is of course ampere. Okay, here one very important thing, current is also equal to Q by T, charge by time. So what is the dimension for Q? Q is equal to IT. Okay, so the dimension for I is ampere into time. The dimension for Q Dimension for Q is 80. Like that you should know. Similarly, there are different resistivity. You know, resistivity, conductivity. You know, R is equal to rho L by A. So resistivity will be equal to R A by L. Okay. So and you know, according to Ohm's law, V is equal to IR. So what is R? R is equal to V by I. And you know W is equal to VQ. So what is V? V is equal to W by Q. Like that only weaker dimension you will get. What you know, Q is equal to 80. So you know the dimension of V. Once you know the dimension of V, you will be getting the dimension for R. And then once you know the dimension for R, AL, you will get the dimension for resistivity. And conductivity is reciprocal of resistivity. All this, like this, no. The main thing is actually you should know the formula of a physical quantity. Actually from units and dimension up to your semiconductor devices, you know, so many topics are there, so many formulas are there. All those formulas you have to understand the concept and you should remember the formula, so that if you remember the formula you can use in solving the numerical problems what they are asking, and also you will know the dimensions. Okay. This is another actually slides where all the physical quantity is there, their formula is there, and their dimensions are there. Kindly for each this thing, no, try to get different formula. See, this is the formula of Biot-Savart's law. Same B I can write it as same B, see, same B mu H. Same B I can write it as mu naught I by 2 pi D. Same B I can write it as F is equal to Q V cross B. So from this also you can find out the B. Okay, same B I can write it as F is equal to Bill sin theta. See, there are so many formulas for B. Whichever formula comes to your mind, accordingly you find out the dimension. So there are some in the exam they will ask which two physical quantity has got the same dimension. Here some examples are there. Stress, pressure, Young's modulus. They have got the Young's modulus, you know, ratio of stress to strain. Strain no dimension. Stress is force per unit area. So stress, pressure, Young's modulus same dimension. Similarly, torque, work, energy same dimension. Torque is nothing but movement of force. So formula is Rf sin theta or R into F. Okay, dimension for R and dimension for F, you will get the dimension. Okay, like this is another tabular column. Okay, all the formulas are there. Sometimes no, in the exam they are asking what is the dimension for inductive time constant, capacitive time constant. If you write down the formula and try to get the dimension, oh my god, 4-5 minutes will be wasted. See, this is inductive time constant, this is capacitive time constant. Time means the dimension is T only, M0, L0, T. So no need to write down the formula and get. Sometimes you can save lot of time. So this is one tabular column, different physical quantity and the units. This is another tabular column, different physical quantity unit. This is another tabular column. Okay. This is another tabular column. This is another tabular column. This is another tabular column and their corresponding dimensions. This is another tabular column and the dimension formula. And okay, this is another tabular column and formula. This is another tabular column and formula. This is another tabular column. You have to know